Hi folks. Right, today we're going to talk about integration. Now integration in its simplest form can be considered as being the reverse of differentiation. So if we differentiate x to the 5 to get dy by dx, we get 5x to the 4. And you can say that what you're doing there is you're timesing by the power, and then you're taking 1 from the power. Now if I started off with 5x to the 4 and I wanted to get back to here, which is what finding an integral is, like I say, in its basic form, I would do the opposite. So I would add 1 to the power, that's the opposite operation, and then I would divide by the power. And if we look here, adding 1 to x to the 4 gives me x to the 5, and then I have to divide by 5, or 5 divided by 5 is the 1, which gets us back to here. So if we had dy by dx is equal to 8x to the 7, you would think, right, okay, I need to add 1 to the power to get 8 and divide by the new power, which is 8. So my answer is x to the 8. Now what if we had a slightly more complicated one? So say I said dy by dx is only x to the 3. Well, then you would say I would be adding 1 to the power and then dividing by that new power. So my answer is, to y would be x to the 4 over 4. And looking again at a similar one, if dy by dx is equal to x to the 9, I would add 1 to the power and divide by the power. So my answer is x to the 10 over 10. Now there is a small elephant in the room here, because if I had to differentiate, say y was 5x cubed plus 1, if I differentiated that, I would get 15x squared, and if dy by dx equals 15x squared, then if I was to use the rule that we're just using, so thinking about adding 1 and dividing by what you get, then that would mean that y was equal to 5x cubed. So the 1's disappeared. So if I differentiate, the 1 disappears, but when I integrate, we've got no means of putting that back in again. And it's the same regardless of what that number is. If that number was 3, we would differentiate to get that. Coming back, it wouldn't be put back in again. If it was 20, differentiating would make it disappear. You've got no means to put it back in again. So if we started with dy by dx equals this, we're never going to account for this number that could be added on the end. So what we do is we say it's plus some constant. So we have to always think that dy by dx, if when you integrate it to get back to what y is going to give you the function where you add 1 to the power and divide by the new power plus this constant term, and that's an important end result from there. So I really should have had that y equals x to the 8 plus c, y equals x to the 4 over 4 plus c, y equals x to the 10 over 10 plus c. And you would not believe how many marks are lost in exams because that plus c is forgotten about. So please pay attention to it now. Okay, thank you.